All right, thank you guys so much for coming. I'm really excited to be here. I love Chicago. I've been waiting for this event for a while. So thank you so much for having me, and thanks for coming. Good luck hacking this weekend. Real quickly, my name is Kevin Jones. I am a developer relations engineer working at EdgeNode. But I'm also highly involved in the Build Guild, or the Biddle Giddle, as you may have heard it before. And so I'm kind of actually just doing a talk about like the full stack dapp kind of experience, and kind of melding those things two together. So we're going to actually do a lot of like stuff on the keyboard. I do have some slides, but not a lot. We're going to do it in two parts. First, we're going to set up Scaffold-ETH, walk through it, and then we're actually going to go through and kind of like build a dapp and build a subgraph for that. So it's kind of that full spectrum. And talk a little bit about the benefits of using the graph as well. I also have this cool PO-op, so make sure you come find me. Scan my thing, and I'll give you guys a cool PO-op, East Chicago. So this is a really good link. This is the workshop I did for at the House of Web3 in San Francisco for EdgeNode. It's kind of a more thorough, I would say, workshop. Probably takes more like 2 hours maybe to go through. We're going to kind of go through some of it today, so it's a good resource for you guys if you aren't following along, which I know a lot of people are eating right now, so it's hard to hack and follow along. So you guys can use this to get started after you're done today. For some reason the slide always no problems. Okay, so Scaffold-ETH architecture essentially is your front end and your back end kind of all baked together in a Yarn package repo. So it's a mono repo. So it does consist of Next.js, Rainbow Kit. We use Hardhat. You can also use Foundry, which I'll showcase that as well. And then it also uses WAGMI and TypeScript. So there's a lot of assumptions that are made with Scaffold-ETH, but they're kind of good assumptions. When I first got started building in Ethereum, I was like, there's all these different tools, and like, how do I put them together? And so the aim of Scaffold-ETH is to do that exactly. It's just to get you up and running. So it's perfect for hackathons because you literally can just spin it up, and you're ready to start hacking away your smart contract and your front end, and we'll get into it and show what that looks like. So let's kind of stop here for the slides. So yeah, getting started with Scaffold-ETH is pretty easy. You can go to scaffold-eth.io, right, and that will take you to this page. And then you can also go to here and get the GitHub. There's some docs. There's two ways to start it up. You can either use npx create eth, which is an npx command to like spin up. It's kind of in beta right now, but if you want to use Foundry, that's the way to go. That's the only way you can really use Foundry right now. Or you can just use Git to kind of check out the repository. So I can kind of show this off if you want. It's very basic. Let's actually do it real quick in like a new window. We can go npx create eth at latest. And it's kind of this like adventure as you go kind of scenario where you can like kind of pick what you want to install. So you can just type that, literally. It's going to install any kind of dependencies that you need. And then it's going to ask you what you want to name your project. So we could just say like Chicago. And then it's going to ask you what chain you want. So you can use Hardhat or Foundry. So let's just say we want to use Foundry. And then it's going to ask you if you want to install the packages. I'll just say no, so we can actually just kind of set the repo up and show you what it looks like to manually install the packages. And it's going to go out there. It's basically going to check out all the files that it needs to get Scaffold-ETH 2 up and running. And then it just gives you instructions. So you can just go cd Chicago, and you can do a yarn install. Yeah, sorry, I just realized that. You guys probably can't read it very well. So yeah, so you go into the directory where you created your project, and you do a yarn install. And it's going to install the dependencies for you. So that's kind of the benefit of using Yarn in a mono repo style, is it just goes and grabs everything you need. This will take, somewhere between 30 seconds to a minute, depending on your internet connection and your computer, obviously. And this is going to install pretty much all the front end, all the back end stuff that you need, all of the frameworks for connecting your chain to your front end, and then a bunch of other boilerplate code that will get you up and running. So at this point, we could actually just kind of start deploying our chain. So we could say yarn chain, and that's going to spin up Foundry for us, and it's going to spin up all of our test wallets and all that good stuff. But I'm going to show you the other way. So that is one way you can do it. We're going to be using a special build of Scaffold-ETH today. So if you go to the GitHub for Scaffold-ETH 2, so there's two versions of Scaffold-ETH. There's kind of the older version, which was just React. The newer version uses Next.js. The older one also didn't have Rainbow Kit. It didn't have WAGMI. So there's been a lot of work to put into Scaffold-ETH 2 to make it a little faster and a little more performant and a little bit more lightweight. So we recommend using Scaffold-ETH 2. You could use Scaffold-ETH 1, but for the most part, Scaffold-ETH 2 is just that more actively developed branch, okay? But what I want to show is the subgraph package. So there's a special branch of Scaffold-ETH that was written by Simone from Edge and Node, where it's basically just an additional repo inside of the monorepo for the subgraph configuration. So we're going to be using that today. So I've gone ahead and already did the checkout. All of the steps for this, again, are in this kind of workshop. So I've gone ahead and kind of checked it out this way using just like a specific branch when I cloned. Let me zoom that in a little bit. So I just checked the repo already, and I've also gone ahead and did the yarn install for you, okay? So we did that. So if we come over here, we can kind of, I'm using tmux, which is just a terminal multiplexer. It just allows me to have like different windows open in one screen. You can do this all in multiple windows. And the reason why you need multiple windows is because you always have certain things running with Scaffold-ETH. Like you need to run your chain, you need to run your front end, and then you also need to run, if you're using the subgraph package, you need to run it in Docker. So that being said, you kind of need a few windows open, and then you kind of need the fourth window to do your deploys. So you can just keep these up in separate windows. I'm going to go ahead and start it up. So let's do a yarn chain, right? So yarn chain is going to do exactly that. It's going to spin up. In this case, I'm using the subgraph package, which is using Hardhat. It's going to spin up that for us, and that's it, just yarn chain. Then on this next window, we do yarn start. So that's going to spin up React with Next.js, and going to start listening on port localhost 3000. And that's it. So we always kind of keep those two open for sure. And then let's just take a quick look at the code, and let me show you kind of what it looks like. So there is this kind of main package JSON, which has all of these commands that I'm typing in here. So if you ever want to reference this, you can look at that. Like if you want to know what yarn chain does, this is exactly what it does, is it references the monorepo. But anyways, let's dive into it. So inside of the packages folder is where all of the boilerplate code is essentially. And so there is, inside the subgraph configuration, there's already a Docker Compose file for us that's going to spin up the graph. So I'm going to spin it up right now. We'll take a closer look at the graph in a little bit, but I just want to explain to you that that's what I'm doing here. I'm going to do a yarn run-node, which is going to do Docker Compose up. If anyone doesn't know what Docker is, it's just Docker containers that have all of the infrastructure you need for whatever project you're working on. And in this case, the graph is three containers. It's IPFS, Postgres database, and the graph node binary. So the cool thing is you don't really need to know Docker. You just run yarn run node, and it's going to spin it up for you. But if you need to troubleshoot anything with Docker, like you can kind of go in here and see what it does. So now we have the subgraph configuration going, and then in this next window, this is where we'll do our deploys. So the first thing I want to do is do a yarn deploy and do -- reset. So you can do a yarn deploy. If you ever want to force a new contract, you do a yarn deploy reset, and it will kind of force Scaffold-ETH to give you a new copy of your contract. And so it's just kind of an extra thing there. But you can see that when we do the deploy, we get a transaction, we get the contract address, and then we get like kind of like some feedback that shows us how much gas was used. And you can also see that up here in the corner, as we do a deploy, we get some output into Hardhat console because we're using Hardhat console in our contract. And I'm going to show the contract in a sec. And we see like some logging that we're doing, it keeps track of stuff for us. So let's go back to the code base real quick and go into Scaffold-ETH's package. So, into the Hardhat package. So inside the Hardhat, there's this contracts folder. And inside there, we have your contract.sol. This is kind of a, like I said, starting contract. It's really just a reader contract and a state contract that allows us to update a variable. Nothing crazy, nothing fancy in here. We have a string that we're defining essentially here, which is currently set to building unstoppable apps. And then we have like an event that keeps track of as the changes happen to the smart contract. We have some stuff like we set an owner and the constructor. But really the main purpose of the contract is here in the set greeting function. And all it does is it takes in a new string that is payable and it updates that. And it does some other stuff in here like setting a Boolean if they paid some value, and it does some checks, increases the counter. and it keeps track of the counter for all the different senders. So there's just some like basic stuff in here that shows you how to do it, and then it emits this event, right? So we can actually load up Scaffold-ETH now. So we've deployed it. So let's go ahead and load up Scaffold-ETH. So here we go. So it's on localhost 3000. And the main like benefit to Scaffold-ETH again is not only this like yarn package that you can just spin up really quickly, but a lot of the boilerplate code, like I said before, is already written for you. And there's a really cool functionality in Scaffold-ETH where you can just go to this debug contract. So this home page is kind of exactly that. It's just kind of like some interesting, like, telling you where to go for stuff. Later on, you can actually start building your app in here. This is basically the index.tsx file, which is, it tells you where it is. But the debug contracts is really like the secret sauce for Scaffold-ETH. Because what it does is it actually, as you deploy your smart contract, it injects the ABI into the front end for you, and it builds out a UI for you. So you don't have to go in there and start kind of building out some kind of like fields for functions that you might change later, and then you have to go back into your front end and change them. You can just start tinkering around with your smart contract right here out of the box, basically. So we also have these readers, which keep track of the variables that are coming from the contract. We have the contract address, how much balance it has in ETH or dollars, and it tells you what's network we're on. So if I come here and I say, okay, well, we see there's a write function called setGreeting, which I showed you guys earlier, we can update something. So let's say foo, like this. Hit send. And it's going to tell me, like, I don't have enough gas to pay for the transaction. So the first thing you think is, oh, maybe I need to connect MetaMask. But you actually don't need to, because Scaffold-ETH also comes with burner wallets. So this concept of burner wallets is basically an in-browser wallet where a private key has been generated for you, and you don't need to worry about MetaMask or nonce issues or anything like that. You just come in here and say, give me some gas, this little icon, gives me some ETH, and then I can update my greeting. It also gives me like a transaction receipt, so I can see if there's some kind of information I want to see that came back from the JSON RPC. I can look at that. But for the most part, we can see now that the greeting has been updated just by calling that function. So nothing crazy, nothing fancy. And then there's also this example UI, which has some kind of examples of how you would create like a button, how you would create a field object, and how you would submit a transaction. And then you can see here that like this example also sends some value. So currently, like the premium is set to false. If I come in here and say bar, hit send, now it's going to increase the counter by 2. It's going to show me some like little pretty UI. And if I go back to debug contracts, we can see that Boolean was changed based on the logic in the smart contract. So you can see how like you can get up and started pretty quickly with Scaffold-ETH using this. And so one thing I want to talk about, let's kind of go back to the architecture slide real quick and kind of go through a little bit more detailed about why the graph is useful as well. So I think everyone knows what a smart contract is. I can probably skip this slide. But everyone knows that the Ethereum virtual machine is a state machine, right? So smart contracts are what kind of like govern that state, right? We have essentially this kind of data object that keeps track of updated information. In this case, we're looking at like the CryptoPunks example, where we have all these NFTs that essentially are saved in the blockchain as these kind of like data store objects, right? And we keep track of the values for each particular thing that we care about. In this case, it's an NFT, so we want to know who the owner is, what the NFT ID is, and then like where the URI is for the metadata, right? And as you kind of we did some transactions, we know we want to update the state. And most smart contract engineers know that if you create a function, you also want to create an event that is broadcasted that keeps track of that information for your front end, and also so that it's if someone's able to listen to it, essentially, right? But there's one problem, particularly just with out of the box using the Ethereum network, and that's mainly that there's lots of transactions going on, right? If you look at these protocols, this is just an example of various protocols. There's a lot of noise in the Ethereum blockchain, and especially if you have like a front end and you're trying to get like detailed information about different protocols, it's really hard to find the data that you need by calling an RPC. Really, when it comes down to it, the blockchain initial architecture was you would write your front end in something like, Next.js or whatever, and you have your HTML, your CSS, your JavaScript, and then you read and write from the blockchain, right? You propose transactions, and then you do like RPC calls to read the data from the blockchain. But there's issues with that mainly because the Ethereum virtual machine is really incentivized more for writes. Like the security model for the consensus is really, okay, you pay some gas to update the state, but there's no incentive layer for reading the data. And it's really not designed, like if the JSON RPC endpoint was really not designed to be used by front-end applications. It was really designed to manage the node, really, right? So there's this problem, and there's also this problem with latency, because if you want to get large amounts of data, or if you want to get like you want to make a lot of calls, you have to do multiple RPC calls, and so it's inefficient. And so we've seen actually in the wild like something like this, where someone is going through, and like in this case, the developer wanted to get all of the NFTs that a specific smart contract owned. And if you do something like this, each RPC call can take 100 milliseconds. So the minute someone has more than 10 or 20 or 30 NFTs in their wallet, this could easily take 10, 20 seconds load time in their front-end application. So it's kind of inefficient. And so you also have this problem like of historical data too. Like if you want to get like, let's say for the CryptoPunks example, like you want to see like who owned the CryptoPunk at a specific state or a specific point in time, it's very difficult to do that with an RPC. You have to know the exact block number, or you got to go through all the blocks and find out when it was transferred, and it's a mess. It's pretty much impossible to do. And that's why this is like blockchain data is a huge problem, and it's hard to solve, but hopefully the graph will explain to you why that's beneficial. And so really what we want to do is get something like this. We had our data object that keeps track of the IDs, the owners, and metadata, but we also want to see like historical data, like what happened at a certain block number or what happened at a certain time on the blockchain. So this is where the graph kind of comes in too. The graph is a decentralized network. So the concept is that we give APIs or subgraphs that are configured for the actual blockchain data that you care about if you're a subgraph developer. We also index data for like IPFS and now Arweave. So there's a lot of power there to actually index the data in an API way, in a decentralized way. And currently the graph serves anywhere between 1 to 2 billion queries per day. So it's highly used. I mean, that's a lot of traffic for any application. And so specifically for like Web3, it's pretty powerful. And so what we actually want to do is something like this, right? Where we have a modern architecture where we still use our front end, right? Which is Next.js or your JavaScript application. Maybe it's deployed to something like IPFS or Filecoin or some other like, static file serving. You still have the blockchain and you're still writing your transactions to the blockchain, but for like reading the data, you have this kind of separate layer where the graph sits in, which is like an index protocol. So what the graph does is exactly that, is you define some configuration for how you want to index your event data on your smart contract, and then you expose it in a GraphQL API. It's easier to use. And so what you ended up with the first example, where we have this kind of for loop that we're doing to get all these RPC calls, gets into this like very pretty, and who's here as a front-end developer? Okay, so you guys probably have seen something like this. This is a GraphQL query, and so the graph highly relies on GraphQL to efficiently like serve, right? It is a query language, and so it's optimized for querying data, and so it's very powerful when you have like something like blockchain where there's lots of data, right? So it is a decentralized protocol. There's over 400 indexers worldwide that are indexing this data. And the idea is like the network is a open, decentralized network that everyone owns the data. There's no like concept of like centralization. The data is redundant, right? You can deploy your data onto the network, and it can be replicated, right, across all these indexers, and it makes it extremely fast and very cheap. And so the concept is like we want to lean towards a global API for blockchain data. So truly decentralized apps is kind of like what we are like aim is like the best vision for developers. And so when you're thinking about today, like building apps, think about it. How can I make my app fully decentralized, right? Truly open, permissionless, all the core concept of building an app. So what is a subgraph? So I talked about it briefly, but basically a subgraph, you can think of it as a database or a data object that's stored all of the information that you really care about as a developer. So if you're writing a smart contract, you write a subgraph, and the subgraph essentially keeps track of all of the event data and keeps it in a easy-to-query Postgres database on the indexers and exposed with a GraphQL API. Okay? So this kind of like mess that we see with like all these transactions going on, you can think of it as something like this. Each particular protocol or application has its own unique subgraph with this organized data structure where you can query that. And by the way, there are example subgraphs for all of these available as well on the graph.com/explorer. I think that's the URL, but it's the Graph Explorer, and you can actually query this stuff now as well. So this is kind of what the architecture looks like. You still have your front end, right? So you have your dapp, your front end application, right? And you still have your smart contract deployed, right, on Ethereum. But instead of having to do reads from the blockchain, you're still proposing transactions to your smart contract like you would normally do through the dapp. But as that smart contract emits events, there is a process called graph node. And graph node is kind of like the workhorse that keeps track and listens using some configuration files that I'm going to show to index that data. That data is then stored inside of the cluster in Postgres and then exposed with a GraphQL API, right? And then as you program your dapp, instead of using our ETH calls to get data, you essentially just do one simple GraphQL API call to get the data that you care about. And this magic really happens here in this kind of like mapping configuration, which essentially is written in assembly script, and it is a WebAssembly module. And so what happens is as you deploy your subgraph, you also deploy a mapping, and the mapping is kind of like, we call it the handler. It handles all of the events that happen, processes them, and then puts them in the data store and then exposes them with GraphQL. So this is live footage of what a subgraph actually does. I still want to know how this works, if anyone can tell me. No one's been able to tell me yet, so I don't know. I'll give you a wait. Okay, wait. All right, it's very powerful. I don't know. So yeah, so we get the idea. So let's see. So let's kind of dive a little bit more. So let's go back to what we were doing. And let's take a look at the code real quick. So we have this basic your contract.sol, right, that we have. It's emitting, we know it's emitting an event, right? Because we can come up here, we can see the event, right? And I mentioned it already. I think everyone knows what an event is, but an event is really everything you care about that's happening in your function. So in this case, we're keeping track of everything. We're keeping track of who set the greeting, what the new greeting was. We're keeping track of whether there was a premium paid. So was it the Boolean true or was the Boolean false? In other words, did they send some value? And then how much was that value, if it exists, right? So we're keeping track of all that stuff in the event. And then we emit that event right here, right? Where we say like, all right, there's been a greeting change. The person that sent the transaction is the sender, the message.sender. This is a global variable available inside of Solidity. So message.sender is who signed the transaction for that function when it was called. We have the new greeting that's passed along as a string, right? Then we have the value, which is also a global variable. And then we have some values that are set if it's greater than 0, otherwise 0. So we're emitting that stuff here. And then we can take a look at the subgraph configuration. And we can go to, we already showed graph node, which is the Docker Compose file. You don't really need to understand that. Just know that everything is running in Docker. And then we can go to here and look at the subgraph YAML. So a GraphQL configuration is really 3 things. So there's this thing here, which is called the manifest. It's like kind of what ties everything together. And the main things that exist in the manifest that are important is the contract address. So in this case, we have the contract address. We have what network it's on. So if you guys are running, like Scaffold-ETH is all local hosts. So we're using Our stack is in Docker running localhost. We have our backend running localhost. So you can just use localhosted here at this point. If you wanted to switch to a testnet, you can do that. I don't really cover that in the workshop, but I do cover that in the other workshop link, and there's a video there that explains that in detail of how to get to that point. But and then we have the entities we care about. So you can think of entities as the data objects, or like, you know, what are the things you care about inside of what you're trying to organize in a schema format, which we'll get to in a second. So in this case, we have the greeting that we care about, and then we have the sender of the greeting, who updated the greeting. And then we have this handler. Oh, sorry, we have the ABI. The ABI is also important. The ABI, as you guys know, is the application binary interface. It's really how it's kind of like the map to your smart contract, right? And then we have this handler. So I mentioned this earlier. So the handler is assembly script, and it is what handles all of anything that happens in the smart contract. It's kind of listening for those events and then processing that. And so we can kind of say this is just like I said, the manifest. It's kind of like the overall high-level view, right? Then we can look at the schema. So if we go to source and go to schema, then we have the data object. So anyone who's familiar with GraphQL or just deployed GraphQL probably recognizes this. It's basically, in this case, we have two entities. So the type is the entity name. So earlier we cared about the sender and the greeting, right? Because we have this contract that's emitting those events. And we can organize that data in a way that we care about. So we can care about the ID, which is generated randomly based off the block or the hash of the transaction. We have the sender, who sent the transaction, what their greeting was, what was the Boolean, the premium, was it true or false? And you can see how there's defined things, like you basically are defining what kind of data you want to store. And so this is already written for you. And my workshop that is on the link walks you through creating a new event and creating new schema and all that stuff. So it's a good way to kind of understand this a little more. But then you can see like when it was created. And then we also have this one, which is the greeting, which is derived from. So here we're keeping track of all the senders, and then we're also keeping track of all the greetings that they update, right? So these are kind of like linked entities. I'm not really going to get too much into that, but these are derived from entities, which means that they have a relationship data inside of the GraphQL query. So that's very useful for optimizing data, but I'm not going to get too much into that. And then we have the mapping file. This is probably the most confusing part of the whole thing because it is kind of, assembly script is a subset of TypeScript. So it looks very similar to TypeScript. So anyone who's familiar with TypeScript probably can recognize and kind of make their way around this file to do things. But the important thing is we have inside of our subgraph configuration, we have a event that's being emitted. And then we have this handle greeting change, which is the handler, which is defined inside the mapping. So what we do here is we import the contract, the greeting change object from the contract. We also import the schema, which is here. So we know how we want to store the data, right? And then inside of this, we just have this one function that is a handler that's going to be executed on Graph Node when we deploy it. That's going to be listening, essentially. So it's listening for events that are called greeting change, and it's doing things, right? It's converting some stuff, like to hex string. We see if it already exists. The sender already exists. If we do, we load that sender. If the sender is null, then we create a sender. So there's some interesting logic in here, but the base thing is we're basically listening for the events, taking the data we care about, and then importing them. And then the most important thing is right here at the bottom where we save both of the entities. So we take that data object and then save it in. And then that's going to save it into Postgres, and it's going to expose it. GraphNode's going to then expose it in the GraphQL API as a data object. So let's see it in the wild. So we've kind of walked through the basics of like setting up the front end, the back end, our Docker container. We've deployed our contract, we've made some changes to our contract, but now we want to actually ship our subgraph, which is already written for us. So we can do that by just doing yarn local create first. You only need to do this once. What it's going to do is basically create the subgraph configuration inside of the Docker that's going to expose the GraphIQL endpoint so that we can query it and kind of experiment with it. And then we just need to do a yarn local ship. So what that's going to do is, has anyone here deployed a subgraph before? No? No show of hands? Okay, cool. So I'm excited. Everyone here should do this at some point tonight or tomorrow, because it's really, really easy, you'll see, to query the data we care about. So it's basically going to go through, it's going to copy across like the ABI, it's going to just make sure that the subgraph configuration is free of like any errors, like you may have like messed something up. If there's an error, it's going to tell you, like, hey, something's missing from the handler or something like that. There's no, maybe a variable is missing. But basically, it's going to go through and compile it, and then it's going to want to deploy it. And then it's going to ask you what version you want to use. So in this case, you can think of the versions of your subgraph should be lined up to your smart contracts versions. So as you add a new function to your smart contract, you should probably iterate on the version of your subgraph. So we'll just do 1. So it's going to compile it. It's going to send it over to the manifest and all the files to IPFS. It's going to then expose the data object here inside of this URL. So we can grab that. And let's go to here, paste that in. Okay, so we have this pretty GraphQL query thing, and we can let's just close these, and let me show you something here. So we can say new, and we can go to Explorer. So GraphQL is very powerful because based on the schema, it builds this kind of cool Explorer for you so that you can explore the data. So we could go in here and say, okay, well, we want to look at the greetings. We can say I want the first 5 or first 10 in this case. I want to know what the ID was. I want to know what the greeting was, what the premium was. And then I also want to know the sender. What was the sender's address? And then hit play. And then we were able to just get that data, right, exposed in one easy-to-query GraphQL API. So we don't have to do any ETH calls. We don't have to do this looping thing. We just make one HTTP call at the endpoint, and we can get the data object that we care about, and then we can parse that. So what does that look like in your front end? So let's go back to VS Code. And I haven't really touched on the front end yet, but the cool thing about Scaffold-ETH is it does come with all the boilerplate code for you and those kind of debug contracts tabs and a way for you to explore the data. We can assume that if you're a front-end developer, if you have a front-end developer, then you can kind of hand it off, and he can start doing some stuff. And I'm going to get into like some reference for that to make it easier for your team. But more importantly is I just want to show the pages directory. So inside of the Next.js folder, there is a couple things that are worth note. One is the scaffold config. So here you can update the chain. So if you want to switch to like Goerli or Sepolia or something like that, you can change that here, which is really useful. And then you can also you can just deploy your contract to a testnet. But I want to touch on the front end. So if we go to pages, and then we go to example UI, inside of, sorry, not pages, components. So there is pages, which has the index.tsx file. And there's also the example UI there. There's the debug contracts folder that kind of shows you how it works. But inside the components folder, so we do use components, there's an example UI folder, and then inside there's a contract data TSX file. And if we go into here, we can actually look and see how you query the data with GraphQL. So if we come down, here we have a const, which is just a variable that defines what our query is. And so you can see here, I've just basically put in the GraphQL query into the variable. And then I've used GQL and use query to essentially formulate a GraphQL request. You can set a poll interval if you want, like if you want to pull the data over a certain amount of milliseconds. In this case, it's 1,000 milliseconds. And then we can see here that we're actually console logging that data in a greetings data object. Okay, so the example is really here for you already. None of the front end really is using that data, but let's take a look at what it looks like. So if we go to Scaffold-ETH, and then we go to example UI, and then we go to view, developer, view source, oh, sorry, not source, view, developer, developer tools, and then we go to console and hit refresh. And we can see here that we're actually logging the contract data inside of here. I know it's really hard to read. Oh, there we go. So we have this greetings data object, and we look inside there. We can see the data. Here it is. And then there's 2 greetings, and here they are in an array. So then you could take this data and display it in your front end however you want, right? So if you care about like the first 50 objects or whatever, then you're kind of set. Okay, so inside of my repo, the workshop, all the way at the bottom, there's kind of like some detailed documentation for like if your team wants to be able to, interact with WAGMI. This is a list of all the WAGMI hooks that are available, because we use WAGMI. There's also, so Scaffold-ETH has its own set of hooks. And so if you want to understand how those hooks work, you can go into there. Scaffold-ETH also has its own components that are available as well. So these top three things are really useful if you're a front-end developer and you want to learn how to like build some stuff out there. And then there's also a bunch of other resources here. So these are really, really valuable. Since we have some time, let's actually go through and like add some changes to our smart contract. And so inside of our example, we have, we can actually probably get through and actually showcase how to add an event and add a new subgraph configuration. So let's do that. So let's say we want to add a new event, okay, and a new function. So we want to, let's assume for a second, we want to send a message on the blockchain. This is probably not the most ideal way to do it. But we can create a function called send message, and then we can take in a value of who that address is going to go to or who the message is going to go to. And then we can also take in a message as a string over call data, and then we can make that externally available, and then we can emit an event based on the data that's passed in that transaction. So let's do that real quick. Let's go to our hard hat packages folder, go to contracts, your contract, and let's just create that stuff. So we have our contract here. Let's just go right below, and we'll add an event, and we'll add a new function. So here we can see we have highlighting, so we know that everything looks pretty good. Let's save that. So again, this is just going to take in an address, take in a string, and then send it across as an event in the contract. So if we have a new deploy, we can just do yarn deploy, dash reset. So it's going to take our smart contract that's been updated, recompile it, update it. It's going to inject the ABI into our front end for us automatically, and it's going to allow us to start testing. So we can go over here, and we can go to debug contracts, and we'll get a new block, right? Now we have this new send message. So let's send vitalik.eth a message. So you can see here we got this cool like functionality as well where we do ENS resolution. So it will resolve the ENS address for us. And then we can say like, hey, what's up? Like this, and hit send. So there we go. And we get a receipt. So we know it was sent, but we don't have anything in our front end, like where did it go? It went on the blockchain, it was an event, but we don't really have anything to show for it. So let's instead start querying the data for our messages with a subgraph. So inside of inside my workshop, we have the steps to do that. Let's go here, and I'll walk through them with you. So the first thing is we need to create the schema that we care about. So in this case, we have some more objects that we care about. We have the message, we have the messenger, and then the receiver. So we have now we have 3 objects. So we can grab the schema and the entities, and we can come over to our subgraph configuration. So in this case, we'll go to subgraph, we'll go to source, and we'll go to the schema, and we'll just add these additional ones. That's it. So we just added those to existing ones that we already have. So again, if you had a smart contract, you might care about certain things. You would design your schema around the stuff you care about. We'll save that. Then we need to add the entities here to our manifest. So again, we talked about it before, but we have this subgraph YAML configuration, which defines the address we care about. It defines the network we care about, and it also defines the entities that we want to actually index and store. So in this case, we'll put those in here. So we have the message, the messenger, and the receiver, which are all defined in here. I saved that. Yep. Now we can also add a handler. So as I mentioned before, if you want to process data in the graph, then you need to handle that data. So we just add an additional handler. We still care about the greetings in this contract because the function's still there. But we also want to add this new handler, which is going to track the send message function. And here you can see it takes an address, another address, and a string. And we're going to use the handler called handle message, right? We can save that, and we're good. So if you've started making changes to your contract, you're going to need to regenerate the ABI because we've changed the ABI. The old ABI is not going to work anymore. So ABI copy is a command that's going to take your new ABI and inject it over to the subgraph package for you. And then CodeGen is going to generate all of the code configuration that it needs. So we can do that. There we go. So it successfully generated it. And then we can come in here and then we can start adding the mapping. So the mapping, like I said, is probably the most complex thing when you start building subgraphs. But we can load it up and kind of, I'll walk you through it here. So let's say we have our mapping here. So we're going to use the same mapping file, but the main difference is that we want to actually import the send message now from the schema, or sorry, from the contract. So we're going to import the send message, which is just the event, essentially. And then we're also going to import the stuff from the schema. So in this case, we're just going to add to the existing one that we have here. So we can just replace this line. But we already have the greeting, the sender, and you can see that it's basically detecting that we're not using it. That's why it's light blue. But we're going to, that'll change as we add our handler. So we can save that. And then the last thing is the handler. So I'm not going to walk through the whole handler, but it's pretty easy to use or to understand if you kind of walk through it one by one. Essentially, all we do is listen for the event, send message. We set some strings based on the values that are coming from the event, so the from, the to, and we're converting them to hex string so that we have them in string format. We're seeing if the messenger exists. If it doesn't, we load it. Or if it does, we load it. Otherwise, if it's null, we create it. And then we create some interesting values about it, like its address and stuff like that. And then we increase the count as well. Then we have a receiver, same thing. We load the receiver. If the receiver doesn't exist, we create it. Same thing with the message. We see if it's available. The message, there's always going to be a new message. So here we're not checking to see if the message exists. We're just taking the message that comes from the event, and we're just processing it and putting it in the Postgres. And that's it. So we save that. So now we have the whole new subgraph configuration. So now we can take it and deploy it. So we can do yarn local ship. And it's going to do things. It's going to check it, make sure it's good, compile it, and then it's going to ask us what version. So we'll do 2, because we've iterated on our smart contract. So we've done that. And then now we can come back to our thing here, and we can do a search. And in this case, let's refresh it real quick. Go to Explorer, and we see that we get new data objects. So now we can go. We care about the messages, yeah. So let's go to messages. We want to see the first 5. We want to know who they came from, the address, and we want to know who they came to, the address, and we want to know what the message is. Play. There we go. So there's my message to Vitalik locally, but it's already ingested. So Graph Node is running behind the inside Docker, listening for the events that are on my smart contract and injecting them. Yeah. So that's pretty much a good walkthrough of Scaffold-ETH. I know there's a lot there to unpack. The benefit is, like I said, going through this workshop probably take you like an hour or 2 to do it on your own, but it's pretty easy to do. And hopefully, if you guys have problems, I'll be around. Yeah, happy to help you guys. And thank you guys for coming. Do you guys have any questions? Yes? Oh, hold on one second. Let's get a mic for...
So, say you're already comfortable building with your smart contracts with like Foundry, and maybe you just want to use Scaffold for your front end, so that you don't have to deal with building your own functionality with setting up WAGMI yourself, or your own input that validates addresses, or currency amount. Like, is that also, I guess, would Scaffold be of enough value if you don't want to do the full stack using Scaffold?
I mean, it sounds to me like you're mostly interested in the front end benefits of Scaffold-ETH. So, I mean, I would just probably use the npx command to spin it up, because there's an option for Foundry there. So it's kind of the same thing. There would probably be some editing that you would need to do for the base version to get it to work. But I'm sure it could be done. It just might take you more time than it's worth than just using the npx command.
Okay. Yeah.
Yeah.
Thank you.
Yeah, no worries. Oh, I think he had a question.
I'm just wondering, what is hard hat?
What is hard hat? Okay, great. That's a good question. I probably should have specified that. So hard hat and Foundry are both like virtualized, essentially Ethereum virtual machine, virtual machines. It's just a way to simulate EVM. So it simulates all the calls that are compatible on Ethereum network. So you can deploy your contract there. It also has a bunch of tooling as well. So like I didn't really get into it, but like you can do testing. So I think it's there. I don't know if they added it yet, but you can do like yarn test. Oh, sorry. Let's see if it's there. Yarn test is going to like actually test your smart contract. It's going to fail because, oh, it did pass. So there's some testing built into there that you can write with JavaScript to be able to test your contract. Foundry also, yarn test works, and it uses smart contract solidity testing as well. So it's really, they're kind of like toolkits for developing on Ethereum. So you can kind of pick which one you want. Hard hat's kind of older, but I think it's more feature complete right now. But Foundry is very popular because people like to use the solidity testing that's in Foundry, which is pretty powerful too, because you can write your tests in Solidity and you don't have to know JavaScript. Hopefully that answers your question.
Thank you.
Yeah. Any other questions? Yep.
What was the URL for that repo, the full stack?
Yeah, so just Scaffold-ETH.io will take you to the repository link, but it's just, if you just Google search Scaffold-ETH 2, it'll pop up. The URL from my workshop, is that what you're talking about?
Yeah.
Sorry. It is, so if you go to bit.ly/fullstackdapp, that will take you there.
Okay, sweet, thanks.
Yeah, no worries. I need a QR code for it. Oh, I can just bring the QR code too. Let me do that real quick. There you go. Cool. Another question? Oh, can you pass him the mic? Thank you.
I was going to ask about the indexers and what it takes to actually host one.
To host what?
The indexers. That you were
Oh,
showing.
for the graph.
Yeah, for the graph.
Yeah. Well, we have an entire indexer community. I think the best thing to do would be to go onto the Discord server for the graph. There's an indexer channel. There's also some documentation. Right now, there's something called Launchpad, which is a Kubernetes kind of solution to deploy an indexer. It's called Launchpad. I personally have not set an indexer up because it's kind of complicated. They kind of recommend that you have like some DevOps experience, but it's definitely a cool thing to do for the community. And if you're interested, we can chat more about it afterwards. Yeah. Cool. Awesome. Another question? No? Awesome. Well, thank you guys so much for coming. I hope this was valuable, and good luck hacking, guys.